Hey guys, this is Mark. In this video, I'd like to demonstrate a chat application that I've been working on using Dropsource and Backendless. It is rather basic, but nevertheless, it is a multi-user chat and shows various features of both platforms that I think you might find rather useful. Let me run the app first so you can see how it works, and then I will go over various moving parts and various tricks that I used in order to build it. So it consists of just two screens. One is the login, which is not so much a login, but more of a kind of a way to get into the application. Here, user types in a username that accepts pretty much any value, and then once you are logged in and subscribed to the chat messaging channel in Backendless, you can start publishing messages into the chat and then receiving messages. So in here, if I were just to type in the trivial hello world and click enter, the message goes out there and shows up. So here are some of the things to point out. There is an auto scroll to the bottom, and let's say if I type in 1, 2, 3, 4, 5, press return, message is published, and when it comes back, you see it actually scrolls down to the most recent message, and so all the messages are right here. I also implemented where any messages of the actual user who is signed in, the username shows up on the right, everyone else is going to be on the left, and then all my messages are going to have this kind of light green background just to point out which messages are yours. This application uses polling for the reason that there is no real-time capability in Dropsource yet, so hopefully it will show up sometime in the future. It will make this application even cooler. All the messages are stored in Backendless, and it right now retrieves 100 messages at a time, but it would be rather simple to implement it in a way where you can actually retrieve all the messages and show them on the screen. So that's pretty much it as far as the actual application. It doesn't seem like a lot. There is this also leave capability, which basically gives you an ability to sign out. So now let me try as a different user. Let's say it's going to be Joe. So right now there are no messages from Joe, and let's just type in hello from Joe. So you see that it's going to be in this light green. There you go. So that's it as far as the functionality. As I said, doesn't seem like a lot, but it actually, while working on this application, a lot of interesting things kind of came to the surface that I had to think about and figure out how to use Dropsource and Backendless. And it's mostly for the part that I'm still going through my learning exercise with Dropsource, and I really love how easy Dropsource makes it to build mobile application. So let's dive in, and I will walk you through the actual structure of this application. So as I said, there are two pages. One is the login, the other is chat. Let's review login. So right here, there are two elements here. One is the input box where you type in the username. And what I did is I added the returned event implementation for this, meaning that when the user types something in and presses return, we need to capture that username, and that is implemented right here. And as you can see, first thing that I do is I hide the keyboard, then I take the username value from that field and I put it into a device variable. So I created a device variable called username, and that username, whatever you typed in, is going to be stored in here. And then I just navigate to the next page, which is the chat page. The question is, why did I store the username in here? Well, because one of the next steps will be to take this username and subscribe to a messaging channel, just so we can start retrieving messages for that channel. In fact, it is implemented on the chat page, and this is the chat page. Structurally, it is very, very simple. It consists of a table view, and this is a dynamic table view, as you can see, dynamic. That table view also contains table view cell, and table view cell has the username, which is where the username of the user that published the message will be displayed, and the label, and the label contains the actual message. There is also a trick here that I implemented, and it uses a scroll view, and as you can see, the scroll view, it's this area right here that uses both the table view and this view right here at the bottom. Why did I use the scroll view? Well, the reason is whenever you press on this field to enter a message, if I didn't have the scroll view, this area would be hidden by the keyboard. But what I wanted to do is this area to actually go up right above the keyboard so you can still see whatever you're typing. And introducing the scroll view that contains table view and this view with the input for the message solves this problem. So that's kind of a little neat thing that you need to know about if you're building something similar. Now, let's take a look at the actual logic that sits right here on the chat page. And first of all, let's take a look at the events for the actual page. On the page appeared, a couple of things are happening. First of all, I run an API request to subscribe to a messaging channel. And this is the messaging channel where I will be publishing messages, and so they actually go right into Backendless. This API is configured with to take that username from the device variable that I showed to you earlier. We'll take a look at it in a second. Right after I subscribe, I issue a request to get the messages from the backend, and this is the API for this. We'll take a look at it in a second as well. And then I create a timer, and this timer, right now I put it to be like super aggressive, which means that the timer is triggered every second. You can actually make it less aggressive and poll for messages less frequently. But here, as far as the Backendless is concerned, it can handle this volume of traffic with multiple users without any problem. So anytime a timer tick event happens, what I do is I get more messages. So first of all, which makes me think that this API right here to get messages is not really needed. So I could just get rid of this one and rely strictly on the timer. So just kind of realize this right now. But anyway, so as this timer is ticking, we're going to be getting messages from the server and updating our view. Then finally, what I do is I set the timer that I created into a page variable. Why do I do this? For the reason that whenever you click or tap on the leave link, you want to stop this timer. In fact, on the left bar item tabbed event, take a look at this, I terminate the timer, and you see in the page variables, I terminate the timer that is stored in the page variables. Then I clear out the device variable, so the username that is stored in there is going to be gone for the reason that we're going back to the login. And then I go back to the login page. So everything is super straightforward at this point. Let's take a look at the APIs that I have implemented here. There are 3 APIs altogether. So the very first API is the subscription. So in here, this is to subscribe, and we're passing a selector, and this selector is just an empty string, and this is done. I just cleared it out accidentally. And this is done just to basically tell Backendless that we want unconditional subscription without any special filtering logic. Next, there's also an API to get messages. So this is the API to get the actual messages from the server. And in here, we send out parameters, which is just the page size, and the page size dictates to Backendless how many objects to return. 100 is the maximum. Backendless automatically supports paging, which means that 100 messages at a time will be returned back to the UI. I didn't bother implementing it fully to retrieve all the messages, although this could actually be done by modifying how this API works with custom business logic on the server side. But anyway, at this point, it's actually just going to be retrieving 100 messages at a time using this specific parameter. Whenever response comes back, this is the response. The data source for this response is just an array of objects. Each object in the array is an individual message, and the data source is bound to the table view, and then message text is bound to let me see, it actually is right here, is bound to the message. So what you do is you just basically drag message text to the label, and the publisher property is bound to the username, and that just takes care of it automatically. And this way, all the messages will just start showing up. Something to point out, remember I had the logic where my messages would show up as with a light green background, and then the text was right aligned, and then for everyone else it was left aligned. To implement this, what I did is I created an event for the actual table view cell. And in fact, if we go to the table view cell events, there are two events, cell loaded and prepare for reuse. I programmed both of them. I'm not sure if I needed that or not. Just to be on the safe side, I can replicate this logic. Prepare for reuse, from my understanding, is triggered whenever we already have a cell in the table view and is being rebound to some other data. So both of these have exactly the same logic. And this logic goes like this. And the first check right here is I go into the data source and I check the publisher property in the response for each individual object. I check whether the publisher is the same as the username, meaning whether the publisher of the message is me, because whoever signs in, their name is going to be in the username. So if this is true, then what we do is we change the alignment of the message to be on the right-hand side. Then we change the background color. This is the light green. And we also change the alignment of the username to be on the right side. If it is false, that means it's some other user, we do the reverse. So we put the message on the left, we set the background color to be this light gray, and we put the username also on the left. And this logic right here takes care of the alignment and takes care of changing the background for your messages. This is pretty much it, I believe. Let me take a look if there are some other APIs. Oh, there's also an API, which is a utility API that I created, the custom service, that I needed in order to calculate the offset of where to scroll this area to. At this point, there is no arithmetic functions built into Dropsource, so I kind of had to make an API call to do some calculation on the server side, and then whenever the response for this comes back, so here's the response is going to be for the event, whenever it's successful invocation, what I do is I put the response from the invocation body into a page variable, which is called offset y, and then I go into the table view content offset y coordinate. I assign it from the page variable into this coordinate, and this really takes care of the auto scrolling to the bottom. Kind of a interesting approach, I would say, because an API call is required to do this arithmetic, but I'm sure as Dropsource adds functionality to do the arithmetic functions on the client side, this would eliminate the need for this API call. So this is the client side, and some interesting things are happening on the server side. So let me switch to Backendless and I'll show you exactly what's happening in my Backendless application. So this is my Backendless app, and in here in the database I created the messages table, and the messages is where all the messages are being stored. It is very simple, probably too trivial for a real world chat application, and contains just the text column and the publisher, which is sufficient for the demo. But something that you need to keep in mind is with Backendless messaging, whenever you publish a message, and by the way, I forgot to show you how the actual message publishing works. So let me just step back and show you that. So in here, this is where a user would type in their message. And let's take a look at the events for this guy. So here, the send text field, whenever you press the return button, this will happen. So in here, we hide the keyboard, we run an API request to publish that message to the messaging channel. So this is the API. And we clear out the text field because that message is gone. It's ready for the new message to be sent. Now, we are using here messaging API to publish messages, and Backendless provides publish subscribe messaging, which is based on ephemeral message storage. So messages are published, they stay in memory for about a minute, and most of the traditional native clients of Backendless use real-time messaging, where that message is automatically delivered to that client. If you use polling, you need to poll frequently enough to get the latest messages, but if the message is gone, it is gone, so there is really no default persistent storage. Since we wanted to keep the message history for our application, as it does right here, you can see all the messages are in a database, what I had to do is introduce custom business logic. And this custom business logic I implemented actually without any code, just to kind of keep the spirit of this demo to be completely codeless without any coding whatsoever. And right here, I added an event called after publish. In fact, for every single API call in Backendless, you can add before and after handlers. In this case, this after publish is an event that is triggered right after Backendless handles default message publishing into the channel. So picture this, you type in a message, tap send, message goes out into Backendless, Backendless puts it right into the messaging channel. That message becomes available for everyone, but specifically for our Dropsource client, we need to take this message and put it into the database. And this is exactly what this event handler does. So let's take a look at this logic. So this is the logic for taking that message and putting it into the database. This may look rather odd if you see it for the very first time, but it's actually kind of easy to read. So what this thing does is it, as you can see, save object in Backendless. Table name is going to be messages, and the actual object, we are creating it right here, create object, and I created properties message text and publisher. You can actually control these properties right here. You can add more properties if you'd like. But here, it's sufficient just to have these two properties. So the message text is going to be this request message. And request message comes right here. So all the arguments for that API event are going to be available as blocks at the top. And we call them context blocks. So what I did is just drag this request message into here, and the message text automatically gets the value. The publisher is going to be a property of the request publish option. So whenever you publish a message, one of the options that you're going to get is the publisher ID. So that's where I get this value from request publish options. And then once this block runs, it just saves this message right in the database, and it shows up right here. So that's very, very straightforward. And once you design your business logic, all you do is you click this deploy model, and this automatically turns into code and starts running instantly. So you can just, in fact, while your application is running, you can make changes in here, deploy it without stopping your application, without impacting your clients, or perhaps you would be impacting by introducing something new and different. But the point is, you can actually make changes to your logic without shutting down your client application. Now, there is also another event handler right here for the before find. Let's take a look at this guy. And in here, what I'm doing is I'm taking the request, and request contains the property called query, and then this object contains a property called query options. And what I'm doing is I'm setting inside of query options a property sort by. And you would ask, why do I do this here? Why do I need to request sort by created? Well, the reason is the sort by property in Backendless is an array. And in fact, you can specify multiple properties to sort by your messages. This will be invoked anytime my Dropsource client, my chat application, retrieves messages from the server. And I want those messages to be sorted by the created field. Well, if I were to take a look at the finding API, the API that retrieves data from Backendless, we will see that this API is right here, get messages. Now notice that in the parameters, sort by cannot be assigned a value because this is an array, and Dropsource doesn't work very well with arrays yet. Therefore, I have to complement this by injecting the sorting parameter on the server side, and I do this right here in Backendless business logic. And this works beautifully because now everything that comes back from Backendless is going to be sorted by the created column. And the created column is built in. Every single object has the created column that is inserted by Backendless automatically. And that's it. That's going to be my application. I'm going to run it one more time. In fact, I will show you that kind of an effect of the real-time messaging where I'm going to log in as Mark one more time. And let me open Backendless right here. In fact, I will need to make this window a little bit narrower. So right here, if I test chat app, so I put it in here, you see the test chat app automatically shows up in the Backendless database because the console that we have is tuned in using real-time messaging right into this database. In fact, if I were to type in a message right from the Backendless console, so I will say message from console, and I will also put it as mark. You see that message automatically shows up in my application as well, which is exactly what you would expect. This is a bidirectional application. So that's pretty much it. Hopefully you found this useful and learned something for yourself, and you can start putting this knowledge and these little bits of information and start applying them in your applications, both in Dropsource and Backendless. Thank you, and as always, happy codeless coding.